Good morning, everyone. This is Mrs. N. Padmapriya, uh, Assistant Professor of Statistics, Sri Sharda College for Women, Autonomous, Salem. In this video, today we are going to see the basic concepts of testing of hypothesis. Let's move on to the video. So in this slide, we just see the basic introduction of testing of hypothesis. In the testing of hypothesis, the primary objective of the statistical analysis is to use the data from the sample to make inferences about the population. From the data, we are drawn from the population. So the main thing in testing is we cannot test the hypothesis for the complete population, and it is very difficult and it is very complex, so that we select the representative sample of the population and study and make inference about the population. So this is the basic introduction about the testing of hypothesis. Next, we just make a different definitions of hypothesis given in different websites. So what is hypothesis? Hypothesis is an educated prediction that can be tested. So the statement which we are going to test it is called hypothesis. So this definition was given by study.com, and in Wikipedia the definition given for hypothesis is a hypothesis is a proposed explanation for a phenomenon. So a complete phenomenon can be explained in a statement. That statement is called a hypothesis. Then in Oxford Dictionary, the definition for hypothesis is given as it is used to define the relationship between two variables. And in Walpole website, the hypothesis definition is given as a supposition or proposed explanation made on the basis of limited evidences as a starting point for further investigation. So in Walpole, it is defined as a definition which gives a basic explanation, and it is the starting point for the further investigation. So next we see what is testing of hypothesis. In testing of hypothesis, we decide whether to accept or reject, that is testing of hypothesis. The hypothesis is tested, that is called testing of hypothesis. So in that, after testing, we have to decide whether to accept or reject a particular value of a set or particular value of a parameter or those of several set parameter. It is seen that although the exact value of a parameter may be unknown, there are often same idea about the true value. The data collected from the sample help us in rejecting or accepting our hypothesis. In other words, in dealing with problems of hypothesis testing, we try to arrive at a right decision about the hypothesis. So we can clearly define the testing of hypothesis is a test of a statistical hypothesis in two action decision problem, that is either to accept or to reject after the experimental sample values have been obtained, the two actions being the acceptance or rejection of the hypothesis. So we define a testing of hypothesis in this manner, that is a test of a statistical hypothesis in a two action decision problem after the experimental values are obtained, the two action being either accepting or rejecting the hypothesis. So we are testing the hypothesis and then we make a decision either by accepting or rejecting the hypothesis. In this video, we just see what is statistical hypothesis and parametric hypothesis. Statistical hypothesis is if the hypothesis is stated in terms of population parameters such as mean and variance, the hypothesis is called statistical hypothesis. For example, to determine the wages of men and women are equal, a product in the market is of standard quality, whether a particular medicine is effective to cure a disease or not, then it is called a statistical hypothesis. That is, the hypothesis is made on complete population. It is generalized one. Then what is parametric hypothesis? A statistical hypothesis which refers only the value of unknown parameter of a probability distribution whose form is known is called parametric hypothesis. So in parametric hypothesis, it refers only the value of unknown parameter of the probability distribution. For example, if X follows normal distribution with mean, mu and sigma square, then the parametric hypothesis is mu is equal to mu1, mu is greater than mu1, mu less than mu1. So here the hypothesis made only on the parameters of the probability distribution. So what is null hypothesis? There are two type of hypothesis, that is null hypothesis and alternative hypothesis. So first we see what is null hypothesis. The null hypothesis is denoted by H naught, is a statement that the value of a population parameter such as proportion, mean or standard variation is equal to some claimed value. It can be 0 or any claimed value. For example, we test the null hypothesis directly. So and then we either reject or accept the null hypothesis. So for example for null hypothesis is H naught M is equal to 5. The above statement is null hypothesis, stating that the population mean is equal to 5. That is, we claim that the population mean is equal to 5. So this is the we claim that to the any particular value. Or else another example can be taken to explain this. Suppose a doctor has to compare the decrease in blood pressure when drug A and B are taken. Suppose A and B follow distribution with mean A, that mean mean MA and mean MB, then the null hypothesis will be MA is equal to MB. That is, I am saying that there is no difference between the drug A. There is no difference between the decrease of blood pressure in both the drug A and B. That is, I am nullifying the statement. That is, there is no difference. That there is no effect between the drug A and drug B. So I am nullifying the statement. That means then I am nullifying the statement of testing. So I say that's why it is called a null hypothesis. Next one is alternative hypothesis. The alternative hypothesis is denoted by H1 or H alternative or HA. Okay, is a statement that the parameter has a value that somehow differs from the null hypothesis. So here the null hypothesis, it is if for before example I say that there is no difference between the drug A and drug B. Then the alternative hypothesis will be there is a difference between the drug A and drug B. If there exists a difference, then either a drug A will be more effective than the drug B, or drug B will be more effective than the drug A. That is called the alternative hypothesis. The symbolic form of the alternative hypothesis must use one of these. That is, either it should be not equal to 0 or it should be greater than 0 and less than 0. That is, it should be there is a difference between two drugs. Either drug A is efficient than drug B, or drug B is efficient than drug A. So before forming our own hypothesis, we have to consider one thing. That is, if you're conducting a study and want to use a hypothesis testing to support your claim, the claim must be worded so that it becomes the alternative hypothesis. So what if you want to conduct an experiment or and test the hypothesis? First thing is what we are going to claim, we can make it that as a alternative hypothesis and make that statement nullify and make that as a null hypothesis. Then in testing of hypothesis, there are four steps. First thing is we have to clearly determine what is our objective of the testing of testing. And the second one is we have to very clear about our null hypothesis and alternative hypothesis framing. And third one is we have to make sure what is our test statistic. From that test statistic, we have to make the decision whether we have to accept or reject the hypothesis. So these are the four major steps in the testing of hypothesis, and that basis of this test statistic only we will make the decision of accepting or rejecting the hypothesis. So the test statistics is a value used in making a decision about the null hypothesis and is found by converting the sample statistics to a score with the assumption that the null hypothesis is true. So in this test statistic is made purely based on the assumption that the null hypothesis is true. Okay, so the test statistic is compared with the parameter in the null hypothesis is called test statistics. So this test statistics will be calculated. This is an example for a test statistics, that is x bar minus mu naught divided by square root of s square by n. This follows t distribution with n minus 1 degrees of freedom. This is the test statistics for a single mean. Okay. So next concept, the main important concept in the experimental design is the critical region. The critical region or the rejection region is the set of all value of the test statistic that causes us to reject the null hypothesis. As I previously told, this test statistic is completely coined on the assumption that the null hypothesis is true. Okay, so that's so the set of all values we obtain from the test statistics will make us to reject the uh, null hypothesis. Okay, so in this graph, in this picture you just see the acceptance regions and the rejection region. The acceptance regions is the 95% of area, and the rejection area is the another 5% of the area. So this is the acceptance and rejection region in case of a two-tailed test with 5% of significance. So next, what is significance level? A significance level is denoted by alpha, is the probability that the test statistic will fail in a critical region when null hypothesis is actually true. So when the test statistic is it falls in the critical region, that is the test statistics falls in the rejection region when the hypothesis is actually true, that is it is falls in the rejection region, but when the actually it is true. So the common choice for alpha will be, maybe it is a kind of error actually. So the common choice of alpha will be 0.05 and 0.01 and 0.10. This alpha is nothing but the how much error we can admit in testing the hypothesis. That is the significance level. Actually, significance level is an error region where the the test statistic value falls in the rejection region when the uh, when your null hypothesis is true. Okay, so this is actually an error component. Okay, so this choice for alpha will be 0.1. That means 5% of error can be admissible. Okay, so this is the level of significance. Next, we see what is critical value. A critical value is any value that separates the critical region where we reject the null hypothesis. So critical region is nothing but the rejection region. Okay, so the value which separates the critical rejection region is called the critical value from the value of these test statistics that not lead to the rejection of null hypothesis. The critical value depends on the nature of the null hypothesis, the sampling distribution that applies, and the level of significance. So this critical value is one of the major important concept in the testing of hypothesis. So this mainly depends upon the null hypothesis, what you are framing, and the distribution of the sample, and the level of significance of the test. Okay. P-value or a probability value is the probability of getting a value of the test statistic that is at least as extreme as one representing the sample data, assuming that the null hypothesis is true. This null hypothesis is rejected if the p-value is very small. That is, if your p-value is less than 0.05 or less, then the p-value is rejected. That is, the null hypothesis is rejected. So next we will see what is two-tailed test. If the alternative hypothesis contain a not equal to symbol, that is, if it is not equal to symbol is present in the alternative hypothesis, the hypothesis test is a two-tailed test. In a two-tailed test, the test each tails as an area of 1 by 2 of P. So here the example for null hypothesis is given, that is H naught is equal to K and H naught is not equal to K. That is sorry, H naught mu is equal to K and H alternative mu is not equal to K. Either mu can be greater than K or mu less than K. It is not particularly defined in the alternative hypothesis. If it is given it is not equal to K, then it is the two-tailed test. Either it can be less than K or it can be greater than K. As I told, that is that the effect of a drug of A and B is not equal. If it is not equal means it can be drug A can be greater than B or drug B can be less than A. So this is called a two-tailed test. So what is right hand test then? If the alternative hypothesis contains a greater than symbol, the hypothesis testing is a right hand test. The same example, if mu is equal to K is the null hypothesis, then the alternative hypothesis is mu greater than K. That is, it is greater than K, then it is a right hand test. Similarly, the left hand tail test is if the alternative symbol contains less than symbol, then it is a left tail test. So next is how to make a decision based on the null hypothesis. We always test the null hypothesis. The initial conclusion will be one of the following: either to reject the null hypothesis or to accept the null hypothesis. Either the rejecting the null hypothesis or to accept the null hypothesis. So but we are going to make the decision either by accepting or rejecting. What will be the decision criteria? The deciding criteria will be reject H naught if the test statistics falls within the critical region. So if the test statistic value falls in the critical region, we have to reject the null hypothesis. If if the test statistic does not falls within the critical region, then accept the null hypothesis. So this is the decision criteria for the testing of hypothesis, that is based on the test statistic value. This is based on the p value. So p value is the probability value. If that p value is less than or equal to alpha, where alpha is the level of significance, that is like 0.05, then if the p value is less than alpha, we reject the null hypothesis. When the p value greater than alpha, we accept the null hypothesis. This is the decision criteria both in the test statistic value and in the p value. So then what is the confidence interval? Basing on that, we basic basis on the test statistics, we make the decision of accepting or rejecting the null hypothesis. After make the decision, we have to find the confidence interval. The confidence interval is nothing but estimate of a population parameter contains the likely values of the parameter. So how much in how much interval the and the test statistics is used to fall in the interval, that is called a confidence interval. Reject a claim that the population parameter has a value that is not included in the confidence interval. So based on this based on this, we this in this testing of hypothesis, there is a possible case of rejecting H naught when H naught is true and accepting H1 when rejecting H1 when H1 is true. So this is called a possible error, that is possible bias in the testing of hypothesis. That is classified in two types, that is type 1 error and type 2 error. First we see what is type 1 error. A type 1 error is a mistake of rejecting the null hypothesis when it is true. Okay, so the symbol alpha is used to represent the probability of type 1 error. It's nothing but the level of significance. That is a kind of error when it arises when we mistakenly reject the null hypothesis when it is true. So then another one type of error is type 2 error. This is called a type 2 error is a mistake of failing to reject the null hypothesis when it's false. Actually it is false, but in case of rejecting, we are accepting the reject the null hypothesis when it is false. So it is true, it is rejected. In case of that, we accept the null hypothesis and when it is false. Okay, so the symbol is represented as a beta, and it is called the probability of type 2 error. So this is the four possible situations that arises in any test procedure, which have been summarized as given below. So actually we can accept H naught when H naught is true, that is the correct decision. But if we accept H naught when H naught is false, there exists an error, that is called a type 2 error. If we reject H naught when H naught is true, there also arises an error called type 1 error. And if we reject H naught when H naught is false, it is a correct decision. So these are the possible situation that arises in any testing procedure. Okay. So how to control the type 1 error and type 2 error? For any fixed value of alpha, an increase in the size n will causes a decrease in beta. So if we increases the number of observation, then obviously the errors will be controlled. For any fixed sample of size n, a decrease in alpha will causes an increase in beta. Conversely, an increase in alpha will causes a decrease in beta. So this alpha is type 1 error and beta is the probability of type 2 error. Once we decrease the alpha, the type 2 error will increase. Once we increase the type 1 error, type 2 will be decreased. So either in any way we can make a proper decision to how to control the type 1 and type 2 error. To decrease both and alpha and beta, increase the sample size. To We cannot increase one error to make suppress the other error. Instead, we can increase the sample size to decrease both the type of error. So this is the hypothesis testing procedure. As I told before, the following 5 steps are followed when testing the hypothesis. First, we have to specify what is your null hypothesis and alternative hypothesis, and then level of significance. And second one is determine the rejection region. Okay, that is second one is determine the test statistics and under H naught, under the assumptions of H naught. And the third one is collect the sample data and calculate the test statistics. And after calculating the test statistics, makes a decision to either reject or accept the null hypothesis. Based on the test statistics and decision, make the interpretation and results in common language for suitable practitioners. So, for example, telling how to interpret, like, for example, H naught here is a cigarette manufacturer claimed that less than 1/8 of the US adult population smokes cigarette. So, if here H naught is rejected, you can conclude that there is a sufficient evidence to indicate that the manufacturer claim is false. If you fail to reject H naught, you should conclude that there is not sufficient evidence to indicate that the manufacturer claim is false. Okay, so this is how we can interpret a decision from the null hypothesis. So like in this video, we just cover what is the basic concept of a testing of hypothesis, what are the different concept like critical region, acceptance regions, level of significance, and type 1 error, type 2 error, left-handed tail test, right-handed tail test, hypothesis procedure for hypothesis testing. I hope you all enjoyed this video, and if you have any suggestions or any comments, please do comment in the comment section, and I can give a link for the quiz that can be included in the description. Please do uh, please do subscribe and make test your knowledge. Thank you everyone.